All right, we're going to start talking about properties of logarithms, and this is lesson 3.3 in the book. All right, so just to review some properties we've already talked about, the basic logarithms. If we have log base b of 1, the only exponent you can raise b to and get 1 is going to be 0. All right, log base b of b is going to be 1. Log base b of b to the x is x. And b raised to log base b of x is also x. And we learned that the first time we went through the reasons why, so hopefully now you can just remember them. So for example 1, beside that, we have 3 raised to log base 3 of 2x. So it's similar to this one right here. So the 3, the log base 3, basically just kind of cancels out. It simplifies away, and you're just left with 2x. All right, and then the natural log of e raised to the x plus 1 is similar to this one. And then, so the natural log of e is going to reduce away, and you're just going to be left with x plus 1. So those were old properties. The new ones are the product, quotient, power rule, and the change of base formula. So the product rule kind of goes with the rules for multiplying when you have the same base, what you do with the exponents. So if you guys remember, like back in algebra, when you learned about, like, if you were multiplying x to the third times x to the second, you would add the exponents together. So because a logarithm is another way of exponent, the rules are going to be similar. So if we have the logarithm of a product, it's the same as breaking it apart and adding them together. So it's the same as log base b of u plus log base b of v. All right, so for example, we have the natural log of 4x. So it is a product, is 4 times x. So that would be the natural log of 4 plus the natural log of x. All right, now we're going to wait on the condensing parts of this chart for tomorrow. So we're just going to do the expanding today. Okay, so now let's look at the next one. We have the quotient rule. So if you guys remember, when you have a quotient with exponents, you subtract them. So it's the same thing. If we have the log base b of a quotient, it's the same as log base b of u minus log base b of v. All right, and I kind of also like to think of, like, if it's in the denominator, it is like being a negative exponent. So if you're pulling that part out of the denominator like we did here, then there's going to be a subtraction sign in front of that logarithm. All right, so let's look at the expanding one. Log base 5 of 5 over x. So it's going to be log base 5 of 5 minus log base 5 of x. Now this one, we can actually go a little bit further because log base 5 of 5 will reduce the same way this one up here does. So log base 5 of 5 is just going to be 1. Right, and then log base 5 of x, there's nothing we can do but just leave that like it is. All right, and then for the power rule, if we have a log of something raised to a power, what we do is we can take that power and multiply by it in the front. So the same thing like when you have a power raised to a power, remember you multiply the exponents together, so that's why this changes to multiplication. And this one you seem to use a lot. So if we have log base 8 of x to the 4th, that 4 that's a power is multiplied by the log. So it's 4 times log base 8 of x. All right, and then we'll do one more rule or formula, and then we'll start practicing with some more difficult logarithms. All right, the change in base formula used to be super important back whenever the only logs you could do in the calculator were common logs and natural logs. Now the calculator is a little more advanced and we don't really use it in here, so this isn't as important as it used to be. But I have seen these questions on the ACT where the only way you can get them right is if you know the change of base formula. So I do want you guys to know it. But if we have log base b of x, we want to rewrite it with a different base. The bases you usually use are base 10, the common log, or base e, the natural log. So what we do is the numerator is going to be log of what's the argument, the x part, over log of the base. So that is the common log that you don't have to write. You also can write it as natural log. So it's the natural log of the argument over natural log of the base. All right, so for log base 5 of 16, we want to write it using common logs and then write it using natural logs. So with common logs, it's just going to be log of 16 over log of 5. And then natural logs is going to be natural log of 16 over natural log of 5. And what we used to have to do whenever we didn't have the calculators that would do different bases is then we would just type that in the calculator and we could estimate it, the value of the logarithm. All right, so on the back of that worksheet, we're going to do some examples that get a little more complex. This first one is not too bad, but our directions are to expand using properties. All right, and for number 1, this one's not too bad. We have log of t over 8. Now, a lot of times this would also be in parentheses, but it doesn't have to. All right, since this is a quotient, we would break it apart using subtraction. And don't forget that if the argument that you're using for your problem comes out of the denominator, then it's a negative logarithm, so a subtraction in front of it. All right, that's it for that one. That one wasn't too terrible. Let's look at the next one. Number 2, we have the natural log of the square root of x. So right now we don't have a product, we don't have a quotient, we don't have a power, but we need to have one of those to use one of these properties. So what we technically do have is a power. So the power that means to take the square root is raising something to the 1/2. So the natural log of the square root of x is the same thing as the natural log of x to the 1/2. And then we can use the power property and bring that 1/2 down in the front. Even though that seems weird and unnecessary, it's actually super helpful for things we have to do in the future with logarithms. Okay, now this one's going to have a lot. So this one we have log base 6 of 3x to the 4th y to the 2nd. All right, now we have a product here, obviously, but pay attention because we actually have 3 different factors you're multiplying by each other. We have the 3, we have the x to the 4th, and we have the y to the 2nd. All right, so we're going to have 3 separate logarithms. So each one of those is going to get its own logarithm. So we'll have log base 6 of 3 plus log base 6 of x to the 4th plus log base 6 of y to the 2nd. So they each get their own logarithm. All right, and we're not quite finished because when we're expanding, we don't leave these exponents as exponents, we pull them down. And they come down just in front of their specific logarithm. So then it would be 4 log base 6 of x, and then plus 2 log base 6 of y. All right. I'm going to do a couple more. For number 4, we have the natural log of the cube root of x over y, right? Now we have multiple things going on here. So the first thing I would do is rewrite the cube root as an exponent. So when you take the cube root of something, it's the same as raising it to the 1/3. So both of these, the x and the y, are both under the cube root, so they are both being raised to the 1/3. Okay, then we have the logarithm of a quotient. So we can break this apart using subtraction. So the x is in the numerator, so there's a positive logarithm for the x. The y is in the denominator, so there's a negative logarithm for the y. And then we would just need to move those 1/3 in the front. And that is it. That is expanded as far as it will expand. Okay, one more, and this is going to use all the properties except change of base. All right, so we have log base 2 of a fraction. The numerator is x to the 4th square root of y. The denominator is z to the 5th. All right, so here we have 1, 2, 3 different variables. And they don't have to be variables because one of them could have been a number, but or multiple of them could have been numbers. But we'll have 3 separate logarithms. If the logarithm for that variable comes out of the numerator, it's positive in front. So the x and the y should both be positive, and they each get their own logarithm. I'm going to go ahead and rewrite that y as y to the 1/2. All right, and then the z is coming from the denominator, so it's minus log base 2 of z to the 5th. Right, and then all we have left to do is to pull the powers down in the front of that specific logarithm. And that's it. All right, so let me give you guys your assignment. This uses all of the rules. So it kind of starts off with some vocabulary, some matching, and then change of base, and then starts getting into the product, quotient, and power rules.